Welcome back. We're still in week 7, and we're going to talk about, continue to talk about airplanes and materials, but really more about materials right now. So the concept is really of different types of materials, different types of structures, and so forth, and the kind of engineering, in particular, how we may be able to test them, for example, make sure they're actually appropriate to use them, and so forth. So let's talk about that a little bit. Okay. When we think about material and properties, I'm going to roughly divide this up into kind of broad groups of things we can imagine, right? So what is the mechanical properties of the materials? We need to understand how do they respond to tension, compression, bending forces, and so forth, which could be a combination of tension and compression. You need to understand that. So we need to have ways of testing for those. We need to understand the chemical properties of materials. By that I mean, how do the materials respond to, say, moisture, to, say, some components in the air, or water and salt. You don't want a material that works fine in the interior of the country to fall apart if it's going landing near a port near the ocean, for example. You need to understand that. So that's part of our material properties and design issues that engineers worry about. Worry about safety. If for whatever reason we have fires or some sort of unfortunate incident in the plane, either on the ground or somewhere else, we need to have something which will give the pilot enough time to deal with it. Right? So we need to make sure that the materials are not rapidly combustible, for example, and you have a fair shot to escape that in case something untoward happens. So we worry about those materials properties also. And then we ask a question, for example, let's say a plane is in operation. You're going to ask yourself, how often should we test it? Once we test all the materials that are used to make the plane, and the plane is flying, are we done? The answer is no, because we need to worry about, do the materials deteriorate at the rate as we might have imagined? What happens when you put a whole bunch of different materials together? How does the system actually function? Does it function in the way it was when it was a new plane, for example? Those are the kind of things we need to worry about. So what airplane manufacturers and users do is periodically take them out of service, test them, and make sure they're doing what they're supposed to do, the assembled product itself. And then the other issue, of course, is that the engineer is always trying to ask the question, is it possible to predict the properties of something actually like an airplane over time? Is there a way to say, you know what, we can safely operate a particular plane over 6 months or 3 months or whatever the time period because our model predicts that it's going to be fine over that time period. Do we have those kind of models? If we don't, can we develop this model? Because it can help the airplane user, the companies along the way also. And just a quick run through some of the simple testing things that you might have heard about, and our students actually do as part of their materials lab. Tension, how do we test tensile properties? Well, we have machines like this that put a material between, like almost a vice, right? Pull them and ask the question, at what point does it actually break? And in early parts of what's called strain or change in the length, the stress or the amount of force that it's going to take to expand it is approximately linear, if you will. Of course, there are many materials where this curve is never linear. You get all kinds of different shapes. But a machine like this can actually help you understand what the tensile properties of materials might be. Compression properties. Similar thing, except instead of stretching it, you compress them, right? In both of these cases, one of the things that you might be curious about is the mean time between failure. For example, you can ask the question, what if we keep these things running like for days on end? Can you predict as to when it will fail? Or can you find out how long you can put them under tension or compression before the thing actually fails? That's also important to know, right? So there are models available. You can make predictive models available which will already make predictions on how long something will actually function and not fail. We have a unique problem with composites. because composite is not one material. For example, it's not aluminum or titanium, but they're made of different type of materials. This is just an example of textile. And if you look at the previous slides, I gave examples of composite materials, right? They're consisting of 2 or 3 different kind of materials. And so this is a very kind of a crude cartoon that shows how we might be looking at composites. What we want for composites is to ask the question, can we look through the composites? Can we see if the composite is as it was when we first made them? And is it able to maintain its properties like that? In addition to mechanically testing them somehow, we need to know, for example, is there anything that we can look inside without having to pull them apart, for example, that will give us some clue as to whether or not the composite is behaving as it is something happening inside it, and so forth. So there are a whole host of non-destructive methods that have actually been developed for looking at planes without tearing them apart, for example. And most of them use, say, some wavelength of light or maybe even X-rays or different methods which allow you to look inside without taking them apart. And this is just, don't worry about the details, but it says essentially you shine a light at something, look at the reflected light, and from that you can understand whether or not the material has changed for the better or for the worse, or no change at all. So, and then this is interesting. I saw this company, apparently they make sensors that can embed inside of materials, which will give you real clues as to how the material is behaving. So the engineer is constantly worrying about how do you monitor the materials after they've gone into service, and how do we learn from how the materials have behaved so we can improve the way the materials are going to behave in the future. So materials design and testing is a very, very big part of what the engineer does for products like airplanes also.